Nature-like technologies at human disposal.
Good morning, my name is Stephen Worsley. I'm the Managing Director of Chlorine, the communications partner of AQUACHLOR Group, well, the parent company, of course, of EEIC. And it's my pleasure to join you today for this morning's workshop. And on behalf of our hosts, EEIC and Emerald, I wanted to thank you for joining us today. I'm delighted to introduce Petr, the CEO of Emerald, and Ramis, head of EEIC's Water Technology Division. Today, of course, is our opportunity to talk about the close partnership between EEIC and Emerald, two companies some of you already know well, and to learn about the world-class technology these two companies are together bringing to release. Ever since the introduction of chlorinated water disinfection more than 100 years ago, scientists have sought better and more efficient ways to disinfect water. Transformative progress has, of course, been made, but this journey is ongoing. And today, as we prepare for ADIPEC, we are thrilled to share the perspective of EEIC and Emerald on their water disinfection journey, and to see a working demonstration of EEIC's AQUACHLOR technology at first hand. And of course, we will be delighted to answer all of your questions. So today is about strengthening partnerships. And on that note, let me pass the microphone to Ramis, who will talk more about EEIC's partnership with Emerald. Thank you.
Thank you, Stephen. Good morning, everybody. It's a pleasure for me to have you all over here to join us in this event where we are showcasing our partnership with Emerald Ecotechnologies and demonstrating our AQUACHLOR disinfection system. So to give you a brief of what the partnership is between EEIC and Emerald, I'd like to make a very small presentation of EEIC. So EEIC is a part of GOBASH Group. GOBASH Group is a very well, GOBASH itself is a very well known in this market. We've been there for almost around 40 plus years, and we have a number of GOBASH basically being a holding company has a number of other entities which are under its umbrella. So, and just, okay. So as you can see over here, GOBASH Group has a lot of other sectors that we deal into. We are into the education, chemical, real estate, investment, technology, healthcare, and energy and utilities, where EEIC and GCG comes into. So EEIC is a part where we do all our EPC contracts. We do basically into oil and gas, we are into water, we are into various other sectors which are basically dealing with energy and utilities. So as a company, we are more than 700 people with 100 plus engineers, 600 plus skilled and unskilled laborers, and we are executing multiple tasks for companies like ADNOC and service providers to ADNOC for HVAC projects, MEP projects. We are doing water technology projects where we are supplying systems as a complete package for EPC with water technology together combined as a one contractor, one solution approach. So this is basically the timeline. So we started off with GOBASH Group in the 1980s, and now we are here in 2024 with EEIC expanding into the water and utility sector. Along the line, we have actually done we have picked up a lot of other well-known companies as our partners. We are exclusive distributors of Honeywell, also Biotechnologies, BMT as a part of GCG, and then now in 2024 we are into the water utility sector. As our expertise, we are into 6 major divisions in our company. Six different business units, as I would say. So electromechanical is one of them, which is basically our most biggest and which carries a big strength in our company. Industrial automation, substation, switchgear, control panels. We do everything in-house. Water, wastewater, completely an in-house division with self-sufficient to give you a solution for all your water, wastewater treatment. We have niche technologies that we have brought into the market. One of them is Emirates Ecotechnologies. Then we are doing also manpower supply and also engineering contracting supplies with GCG as our sister concern. So some of the projects that we have done in one of our smart infrastructure projects, we have done the smart infrastructure lighting project in Abu Dhabi, in Gnatyuk. This is a phase 1 and phase 2. And industrial automation projects for SCADA, PLC, DCS, completely done by EEIC in-house team. We have the substation, switchgears, control panels, again, all completely in-house structure that we follow in the company. Some systems which were delivered last year by EEIC for water, wastewater treatment. Manpower supply, maintenance contracts for major companies around Abu Dhabi and North Emirates. And some of the solution services as we provide for oil and gas OEM parts from our GCG trading department. So as I was saying that this collaboration basically is to bring in a solution that is niche, which is basically something which is quite revolutionary, which reduces the customer's operational cost, which reduces customers' headaches to carry a lot of chemicals and logistics and manpower to deal with disinfection systems and things like that, conventional disinfection systems and things like that. So as a company, we had a lot of interaction with Petr and his team to learn, understand, and to see where we can market this product, how we can bring this product into the UAE market and bring it to the customers and see how it can be well established into their current setups by doing the retrofits. So this is something that we are going to explain it in a very technical detail. We are going to deep dive into a very technical aspect of this product today. And also we will be showing the live demonstration of this product. So you get to know basically how we are differentiating from conventional water disinfection systems. So I'll hand over the mic to Petr and let him take over from here to start the technical presentation of the AQUACHLOR disinfection systems. Thank you.
Thank you. Thank you for coming. It's a pleasure that so busy gentlemen, which we're speaking about for a few years, are here with us today. It's a pleasure. Thank you, all the team from EEIC for supporting in managing all these seminars. Thank you, Petr. I know it was quite a difficult job, especially because the live installation will be there, so it's need quite a lot of things. Ramiz told that my presentation will be technical. Yes, but I don't want to mean that it will be very boring. So please stop me, ask any questions if something is unclear, because today is not the aim is just to make the first presentation, because everybody in this room are already aware of this technology from the second glance. So our target here is to really answer the specific questions which you have about this technology. So mixed oxidants technology was born in USSR, so former Russian Federation, in 1970s. So in fact, the professor, the group of scientists with whom we are still working on, some of them are still alive, luckily, it is more than 50 years of experience in this technology. It was born in 1971 for oil and gas, because in some remote areas of USSR, like Uzbekistan, Tajikistan, there were a few drilling stations, and they needed a lot of caustic, a lot of chlorine for their technological needs. But to bring it from the city, like 200 kilometers, 300 kilometers, it was quite difficult. So the target from the government was to create these chemicals on site. And that is why we started to solve this job. And when we have made the first machines to produce these chemicals on site, we found a very interesting effect, which Mr. Petr, our professor, called like activation phenomenon. So we found that the, let's say, live chemicals, which are synthesized on site, they are more reactive than the similar chemicals which you will just deliver, like chlorine gas or caustic soda. And that was the beginning of this 50-year journey. And luckily, Emerald engaged all this scientific background, all these scientists who are still working with us for different aspects of this technology, like coating of the anode, making ceramic diaphragm, and general technological processes. So I, as a CEO of Emerald, always looking forward for new science, new pilot exercises, development of this technology. And that is what we are doing in UAE for the last 4 years, since the main experience of our company, of AQUACHLOR machines, it was for drinking water disinfection from rivers, lakes, it was for wastewater, of course. We have made a lot of projects in Russia as a main country from where we were born. In Russia, we have installed maybe 1,600 units. It is dozens of water treatment stations, dozens of wastewater treatment stations, and by the Federal Health Ministry in Russia, this technology is authorized for the whole country. Of course, we have also made quite a lot of projects in USA, in Europe, and now our main region where we are active is the Middle East, because this region is definitely developing. And what I like mostly is that people here, they don't only speak about eco-technologies and healthy safety, they really work on it, and we see it. So this is just a small preview. Again, I hope I will not be very boring for this presentation. So two main chemicals which we are using is pure salt and pure softened water. From these chemicals, we produce very strong disinfectant, which we call mixed oxidants, because it consists of a few active oxidants, which can eliminate any type of disinfectant in any facility. Wastewater, drinking water, swimming pools, cooling towers, any of them, being more safe, more effective, and cheaper. So let me start with this table diagram. We just summarized here the most popular disinfectants like chlorine gas, sodium hypochlorite, calcium hypochlorite, chlorine dioxide. I will not be passing through all of this yes and no, it will be very boring. But the core idea of this diagram is to show that the dead chemical, I will be saying like dead and live chemicals, so or stable. And when I say dead, it means like stable chemical. It cannot fulfill all the targets necessary to give good quality of water disinfectant. So some of them, like chlorine gas, they are very dangerous. Some of them, they give bromate. Some of them does not give bromate. So you cannot find a perfectly suitable solution. And one of the key reasons is that microbes are living beings. They develop, they adapt. And this problem is very well known in medical sphere, in oil and gas sphere, in water, that when you use only one chemical, the microbe, they start to develop resistance. For example, NAQAA Desalination plant in Kuwait, second largest in the world, where this year we have made a really good progress. I will be speaking quite a lot about this because it is a real case and it will be interesting for you. And other seawater desalination plants, they are doing, it was just a very interesting information for me. They're not doing shock chlorination for seawater, when they take seawater before reverse osmosis. They're not doing shock chlorination in the same time. So let's say 8 in the morning and 9 in the evening. They are always changing this time of shock chlorination, not to give microbes the ability to resist, because they found that when they do it at the same time, it becomes less and less effective. So it's very just interesting principle. The most popular disinfectants in the Middle East, I can say, is chlorine gas, sodium hypo, and chlorine dioxide. The first one now is being eliminated from the majority of facilities because of it is very dangerous and it gives a lot of disinfection byproducts. Sodium hypochlorite is the most popular because it's quite cheap, easy to inject it into the water. But in terms of safety, it's one of the worst because it gives bromate, it gives triglycerides, it gives haloacetic acids, and it is very weak disinfectant. I will show you some real tests today, which is just a very easy confirmation of this. Chlorine dioxide has clearly won in the competition for potable water, because now in UAE, in Saudi, I think 95%, 90% of desalination plants for potable water, they are using chlorine dioxide because it is not giving bromate, one of the reasons. But at the same time, it is very expensive. We have proved that our solution, for example, is 90% cheaper. I will be speaking about this. And yes, it is not giving bromate, but what we proved at NAQAA, that it is giving chloride, and you should handle 2 very dangerous chemicals from which you created, hydrochloric acid and sodium chloride. And one of the very new problems, which is now being investigated, I have heard it from TAQA, from DIVA, from SIVA, that the usage of chlorine dioxide for potable water has increased the speed of pipes cracks, let's say. So the HDP pipes, they have started to be damaged much faster. And this is now under investigation, but the people with whom I have been speaking come to conclusion that it is because of chlorine dioxide. Let me skip this slide for now. I will now get into some technical part of the presentation. Please bear with me for only like 5-6 minutes, and then we will shift to real cases and not so scientific sort of things. So when we are speaking about mixed oxidants, we are speaking about a variety of oxidants which we synthesize in our cell. This is the cell. We have taken 2 real cells. They are not super beautiful because it is real cells from the real machine. I can just give it for some touch experience. They're made from titanium. So in these cells, we have managed to synthesize a variety of oxidants at the same time because they can work under pressure. All traditional chlorine generators or sodium hypochlorite generators, they just have a plate cells. I will be speaking here about this. And our cell, it is cylindrical, and it is working under pressure. And what we found that when the cell is working under pressure, you can make electrolysis not only of salt, of sodium chloride, but also of water. Water also starts to get into electrolysis, and you can synthesize such oxidants like hydrogen peroxide, ozone from water, not only from salt. This is like the core advantage. The diaphragm, very important part of the cell, the diaphragm which divides anode and cathode, it is made from ceramics. And luckily, last year we have started our own manufacturing of ceramic diaphragm. I think that we are maybe the only manufacturer of electrolysis machines in the world who make their own diaphragm. Because if you take companies like Denora or American companies, they are all using Nafion membrane. It is polymer membrane made by Japanese. And it is afraid to impurities. Our ceramic cell, even if you get dirty salt or dirty water into it, you can easily flush it with hydrochloric acid. And it will be working. You can only crush it. If you will play baseball with this cell, you can crush it, but in operation, nothing is, it's absolutely inert material. And since we are doing all these core parts, we are easily giving 5-year warranty for our cells, because we know it will work more than 10 years. Last year also we have started to make our own coating, the coating of the anode. This is black titanium part, which is going throughout the cell. It is coated with iridium. We buy iridium and we make our own 12-layer coating. Usually it is made 6 layers, we are doing 12 layer, which is also important. So this is cathode, this is titanium cathode, it is not coated. Between is porous ceramic diaphragm, and inside is the anode, coated with iridium. From another way of view, you can look like this. You have the anode chamber, you put salt, table salt solution here to the anode chamber, and this is working under pressure, around 2 bar. So here we produced our mixed oxidants solution. We produce gases and mix them with water. So the final concentration is around 0.1, 0.2% in active chlorine. In the cathode chamber, we produce, as a valuable byproduct, we produce caustic soda solution. The concentration can be from 15 to 30%. Okay, so now I will just briefly get back here. Any questions for now, for this part? Or I can go ahead.
These cells come in one size only, or you manufacture depending on different capacity of the machines?
We basically have 2 sizes. The first is the size, like this. It is around 50 centimeter. And this machine is based on these cells. Second size is twice larger. Same diameter, but twice larger. This cell can give 60 grams per hour. Twice larger, it's 120, 125 grams per hour. So all big machines, the big machines, we're doing on larger cells. But the structure is absolutely the same.
Peter, sorry, may I ask you? Now, for what I understood from you, the cells or the system producing from water the ozone, correct?
Yes.
It has nothing to do with the salt, correct? Is this only if there's water, then because there is oxygen, and then produce then ozone, correct?
Okay.
Or not?
Not exactly.
Okay.
The main product which we produce is chlorine gas. Chlorine gas. And we use salt. You can see here a tank with the salt, sodium chloride. So this salt, it is pumped to the anode chamber. So the main oxidant which is produced is chlorine gas. And when we dilute it in water, it gets into hypochlorous acid. That is why we say that 95-96% of our solution is hypochlorous. So it is chlorine gas which is synthesized and diluted in water. It is hypochlorous. But the core advantage is that we do not only produce chlorine gas, we also produce in small amount, it is relatively small amount, like 1%, 2%, we produce other very fast reactive oxidants. And this gives two key advantages. First is disinfection byproducts, because if you use just chlorine gas, it will give disinfection byproducts, and this is a known fact. But in our case, we do not give them. Why? Because these fast reactive species, like hydrogen peroxide, ozone, they react with organic first, before chlorine can do it. And after this fast oxidation, chlorine does not transform this organic into byproducts. That is the core principle. And second, because we have a variety of oxidants, we can very effectively eliminate biofilms. Because biofilms, it is, you know, like colonies of microbes. I will be speaking about this.
We have a lot of gases are forming. Which one will lead? Because you know, hypochlorous acid or hydrogen peroxide will react. Which one will react? It will start disinfect or it will replace the organic compound. Which reaction will happen first?
Again, ozone, hydrogen peroxide, they will react first. And they will disappear instantly. You will not see them in the network by any sensor, because their amount is very low and they will react first. So the only residual which you will have is active chlorine, which you will measure by the same active chlorine level sensors. And this residual will be better than you have now. I will show these examples later. So thank you for getting through this boring technical part of the presentation. Now it will be a bit more pictures here. So this is just a real photo from one of our assembling room in Russia. In total, our facilities is more than 31,000 square meters in Russia, in different cities. And now we are very actively moving towards making local manufacturing here, with the support of EEIC, with support of NSF organization to certify the local manufacturing here and to get local NSF for this. The patents and certification is not so interesting. We have it, it's a common thing.
Just a question here, what does the certificate actually tell us? Because if you go with and try to substantiate things, so are they all the same? What are these certificates about?
For certification, we have CE certificate and ROHS. This is basic certificates from Europe. ISO management certificate. We have a certification from TÜV laboratory. It's very well-known certification body in Germany, which tested all these machines. And we have also made some very important lab results in NAQAA Desalination plant. I will show you. Yes, yes. By the way, Farah, I forgot to tell you. You have a QR code on the table on this one. Here is all the basic information, like presentations, scientific articles, certificates, patents, so all the things you might need about this technology. So you can just scan it. It is a link for Google Drive. Okay, so getting back to the table, which I have started with, we have just added the mixed oxidants, and not in the marketing targets, but because we really see it. We see that with mixed oxidants, you can be safe, you can eliminate any disinfection byproducts, and you can be very cheap and effective. So, to our mind, to the practice which we have from the clients, this solution can really suit all the key desires of the clients in terms of disinfection. Okay, so let's now go through 3 milestones, like economy, efficiency, and safety. The results which we have got from NAQAA Desalination plant in UAE, from Dubai Municipality for sewage treatment, are listed here. If you take the operational expenditures to synthesize 1 kg of active chlorine, it will be around 0.8 or $1, you can say $1 per 1 kg of free available chlorine. So if you need, this number is very easy if you know how much active chlorine you need per hour or per day. You can just multiply by $1 and you will get your OPEX. The OPEX consists of water, softened water, 8 liters per 1 kg of active chlorine. We consume 1.8 kg of salt, which is a very efficient number, and we consume around 4 kilowatts of power per 1 kg. So this is basically your main OPEX. So comparing with chlorine dioxide, this is real number from NAQAA Desalination plant, we are 90% cheaper. Comparing with sodium hypochlorite, the numbers which we found from Dubai Municipality project, we are 60% cheaper. And in some cases, we are even cheaper than chlorine gas. This will depend because chlorine gas prices, they are very different. In some regions, it is like $400 per ton. In some location, it is $1,000 per ton. So it depends. Speaking about ROI, return on investment, for chlorine dioxide retrofit, it will be around 14 months, which we have calculated for NAQAA Desalination plant. For sodium hypochlorite retrofit, it is usually around 2-3 years, depending on the price of sodium hypochlorite. So again, I have spoken about the core consumables. On average, I will point out one thing here, because quite often people who are thinking about buying sodium hypochlorite generator from China or some cheap one, they're coming and saying, Peter, your capex is higher, 20-30% higher. And we have just a sodium hypochlorite generator. But in this case, you should think, let's say you need 20 kg per hour. So it's around 1 ton per day of active chlorine. And our OPEX will be at least, let's say, 30-40% cheaper than traditional sodium hypochlorite generator. So I want to say that if you buy cheap generator for sodium hypo, for example, you will have for sure like disinfection byproducts, you will have maybe some other technical issues, but your OPEX will be like 2 times higher. So let's say you save $100,000 in capex and buy a cheaper machine, but during the first year of operation, you will lose it because your OPEX will be twice higher. And these machines are thought to work 10 years. So in the long run, you will pay much more for the OPEX. And this should also be taken into account. Okay, in terms of efficiency, I think I will not put too much time here. I will speak about the biofilms. We have made a lot of tests in medical industry, in oil and gas, wastewater, desalination, that we can really effectively remove the biofilms. So for example, this is the pipe with the biofilms in the medical chair. It is the dentistry. And after dosing 0.1 ppm only to the water, in around 1 month, the biofilms gone. This effect is very difficult to achieve with any other disinfectant. This is example, photos are not very good because they were made inside the pipes. It is in USA, wastewater treatment plant. So this was the pipe condition with sodium hypochlorite. This is after 6 days we started to dose 8 ppm of mixed oxidants, and this is after 22 days. So the pipe was cleaned, and that is one of the most important reasons why we give better active chlorine residual. Because with this solution, you can really clean your network. And that was the key argument why Dubai municipality now, they want to shift all sodium hypochlorite in their wastewater treatment plants, Jebel Ali and Al Warsam, because the smell issue is the core for them. They cannot win this because of using sodium hypochlorite. They dose, let's say, they dose it at the beginning of their network, but in the middle of the network, it's gone. They don't have active chlorine residual. Because sodium hypo, it cannot remove biofilms, and they start, it becomes food for the biofilms. They just start to eat it and develop. And of course, smell will develop and develop. With this solution, you can clean your network and give very good residual. And in terms of eco-friendly things, very important in the Middle East. In Russia, we don't care too much, to my regret, about this, and the majority of stations, they still use chlorine gas. Everybody knows that we have byproducts, that it's dangerous, but this tendency is not so strong in Russia. But here it's really strong, so I can speak about this. We just make a very simple picture which illustrates that with the one truck of salt, the truck size in these calculations are similar, around 25 tons. So with one truck of table salt, which you will bring to this station, to your facility, and Emerald machines, you can produce active chlorine in the same amount which you have in 8 trucks of sodium hypochlorite. This is sodium hypochlorite, 12.5%. So we just recalculated in active chlorine. So you can produce 8 trucks of sodium hypochlorite equivalent and 2 trucks of caustic soda, because caustic is produced like a valuable soap product.
For the water, how much water you need and how you get this pure water?
It is reverse osmosis water. Yeah. For desalination plants, they have it quite a lot. So we don't need even to install additional reverse osmosis water. For other facilities, we install just small reverse osmosis system. To produce 1 kg of chlorine, effective chlorine, we consume around 8 liters only. So it is a very small amount. For the majority of projects, even the household reverse osmosis, which you have under the kitchen, for example, it will work. So it's very small amount of reverse osmosis water. This is example of different brine making systems. Brine making system is a system which mixes water with the salt. So this is the most, let's say, advanced level of the briner, which we use for big projects, where they need to store like 20 ton or 30 ton of salt. This is vertical brine making tank, and the salt is fed up here through the truck pneumatically. So it goes directly to the tank, then it dilutes with water, and from these briners you can take it. This is a more Russian style approach, cheaper but still effective. You just unload the salt from the truck to the concrete bath. And this is small brine making systems which we make ourselves. Some of the projects, this is a project where in USA, Atlanta, it's Chemstar company, pharmaceutical company. All this room was full of chlorine cylinders, and it was quite dangerous. It's not very beautiful photo because it was made during the installation process, but the key number here is that we reduced the total OPEX of the company, not just the OPEX for disinfection or chemical, the total OPEX of the company by 20%, because we removed chlorine gas from the facility. So they have substantially reduced the costs for safety, for the areas, and so on and so on. So we calculated all this, and it turned out to be 20% general OPEX of the company, because safety has been increased. So this is for the projects where they need to replace chlorine gas. It's very, very relevant. This is the project in Kazakhstan, 16,000 cubic meters per day for sewage treatment. This is our first big project in Russia. We have installed it in 2007. The capacity here is 38 kg per hour, so it's around 900 kg per day, and it is disinfecting 350,000 cubic meter per day of drinking water from the river. The system is still in place. It has been working for 18 years. Of course, we are changing the cells, the power supply, the pumps, of course, but the system is still live. This is just an installation diagram. I think I will not stop here, maybe in the second part, because we have the machine, it will be easier. But basically, the main components of the delivery set is the main generator. Then you have a reverse osmosis system, you have a brine making tank, and you have a tank to store caustic soda solution, which is a byproduct. That's it. This is examples of relatively small systems which are very good for pumping stations, for transmission lines. For example, one machine in duty, one machine standby, small reverse osmosis, small brine making tank, and each machine can give maximum 3 kg per hour, like this. So you can see the size of this, it is absolutely the same here on the photo, like kitchen refrigerator, which I'm referred to. So 3 kg, in total it is 6 kg. So taking the average disinfection rate, such system with a layout of around 4 or 5 square meters can disinfect 6,000 cubic meter per hour. 6,000 cubic meter per hour. Which is quite... Yes, yes. Usually the dosage rate is 1 ppm. So let's say if you dose 1 ppm, 3 kg, it can disinfect 3,000 cubic meter per hour. 6,000 cubic meter per hour. We have our own very advanced web server, which is my lovely thing, to be honest, because with the projects in USA, UAE, Russia, you cannot live without this. So here we can fully monitor the machine, we can work with the machine, update the software, start, stop. We have all sorts of alarms which we can receive. So all the things are in place. And also we have advanced analytical instruments, so we can measure the stability of the machine in the long run. Any question?
Sodium hydroxide caustic, which is produced, is of what concentration?
Around 20%. 20%. We can regulate it. The maximum which we can give is 30%. If we need to dilute it, we can dilute it up to 5%. So usually it is 15-20%. Yes, please?
Yeah, so the mixed oxidant you produce from this machine can be directly dosed online through the pipe, or you need to store it?
Yes, yes. In 95% of the projects, we dose it online without any storage tanks because, for example, you know, the NORA company is just an interesting example. They have also machines called MIOs, but this is just sodium hypo generators. Why? Because you cannot have mixed oxidants if you store them in a tank, because ozone, hydrogen peroxide, they will instantly disappear if you put it in some tank connected with the atmosphere. So it's impossible. That's why, for many cases, we prefer to dose it directly. Usually we use ejectors, you know, Venturi ejector. So we use a pump, ejector, and all these oxidants are sucked to the water line.
So depends on the capacity of the flow rate, and the production of the machine can be modulated?
Yes, yes. We will show during live operation. The very beautiful thing here is that production of chlorine, of active chlorine, of oxidants, it fully depends on the current level. We have power supply here, AC/DC power supply, which put 5 volts on the cells, usually 5 volts. So if you increase the voltage, your current on the cell will increase, and production of chlorine will increase. If you reduce the voltage, current will decrease, production of chlorine will decrease. And the formula it's Faraday formula. It's known for 100 years. So regulating the current and voltage, we can exactly know how much active chlorine we dose. So in another way, very typical example. Your SCADA system, you know the water flow in the network, okay? And you just give us 420 milliamp signal, 420 milliamp signal to our controller, to our PCB. We have, by the way, I think you will see it. We have quite advanced PCB, which we are making by ourselves also. So we are doing program, we are buying components, welding it, and so on. So we just receive 420 milliamp signal from your SCADA system. We know the water flow, and we know the dosage which we need to make. So we just regulate, based on your water flow, we regulate the production to keep dose same, to keep same dose of active chlorine.
Just a follow-up on the same. In the previous period, you showed us on the caustic production, you put a storage tank in between.
Yeah.
Okay, so what's the main reason if you can dose online and modulate production according to the dosage?
Caustic soda is not produced under pressure. Caustic soda is just gets out from the machine. Sorry?
It's a high product, is this?
Yes, yes. As a separate product, like a 20% solution, it just goes from the machine like by gravity. So it just goes by gravity, and we need to accumulate it. If we don't need to accumulate it, it can be drained, it can be sold, neutralized, many things. But usually we accumulate it in the tank and then dose by the dosing pump to the system. For example, NAQAA Desalination plant, they will have around 1 ton of caustic soda from our machine, but their daily consumption is 5 tons. So all the caustic which we will produce, it's like 20% of their daily consumption. Yeah, so coming to most interesting part of the presentation. I hope everybody are here, still here. So this is NAQAA Desalination plant in Kuwait, 684,000 cubic meter per day, or 150 MIGD. It is governed now by Etihad and Aqua Power. So this year we have installed the first machine in this plant for potable water disinfection. We are not doing seawater, we are doing potable water. And it has been installed in March. Till now it has been running without any faults, and we have made a lot of very interesting research. Today it will be first time we will, let's say, speak about these results in public. So first result which we show to them is that the OPEX reduction will be around 91% comparing to chlorine dioxide, and return on investment is around 14 months. After this, they has become interested and we have started all this process. So you can see the generator, the brine tank, caustic tank, and some distribution lines. Yeah, this is our team which took place. So first, the results will be not visible here, but you can find this report by the QR code and the link. During this tests, you know the story here, when we started to speak with Etihad, the first thing they told us that you need to be approved by World Health Organization. It was a bit of shock for me because I didn't understood it. But then we found that the logic. There is a World Health Organization water quality guidelines. And UAE, they officially recognized these guidelines. So they are fully in line. That means that your machine, if it is connected with potable water, it should be fully in line with all these parameters. So they have made 3 independent tests for all 95 parameters, starting from basic one like color, turbidity, odor, then sulfate, magnesium, heavy metals, and all disinfection byproducts, all sorts of disinfection byproducts, including bromate, chlorate, chloride. So all 95 parameters which are listed in WHO, they are fully in line. There were 3 tests. They have paid maybe $15,000 for these 3 tests. Luckily, we didn't pay this, but the results were good. And here are the main results of our pilot tests. I will give some comments here. So one of the tests were to look how the chemical is behaving in the long run, in the network, let's say, in 8 days. So we have created a small network, and the water which we disinfected, it was circulated there by the pump. So it was like an imitation of the network. Because bromate, it will not be formed instantly. It needs 1 day, 2 days to be synthesized. So this is the results with mixed oxidants. This is with chlorine dioxide, and this is with sodium hypochlorite. So core thing which we proved here is that you can see here active chlorine level. So the initial dose was around 0.16 ppm, and you can see how this dose is degrading in 8 days. So the rate is relatively small. I should say that for all these tests, there was a natural temperature. There were no AC. So the temperature was around like 35, so fully open. It was exposed, the water was exposed to natural heat. Anyway, you can see that the degradation of active chlorine is quite slow. But most important, that we proved that our solution does not give bromate, chlorate, and chloride. You can see that all the results in 8 days, there is no reaction at all. If you take then chlorine dioxide, the dose here was a bit less, but anyway, it doesn't matter too much here. Yes, it is not giving bromate as known, but you can see that it gives quite a lot of chlorate and chloride. And chlorate and chloride is proven thing that they are also quite cancerogenous for people. Yes, the level of the chlorate and chloride acceptable in the specs is higher. Not so small as for bromate, but anyway, it is not good for your health. And with sodium hypochlorite, so the active chlorine was similar, like 135. It was degrading by the similar rate, but you can see that the bromate formation is happening, and you can see the chloride formation is also happening. So for now, it seems like the only solution, mixed oxidants, which is not giving any of key disinfection byproducts for the Middle East. And this was proven.
Peter, this bromate in the sodium hypochlorite, this is coming from behind in the solution.
You mean?
It adds, because you add the solution, the bromate comes in from behind. It's already there in the solution. It's not being formed in the water.
I should say that both ways. You are dosing it with the solution itself, but also some of this will be formed during the days. But you're absolutely right. This is the problem of traditional sodium hypochlorite generators.
Exactly.
Because when you just take the brine, bromide will be there. And when you are passing this brine through the anode and directly go to the water, you will add bromate to the water. In our case, we separate pure gas from the anode chamber. We do not inject brine into the water. From our brine in the anode chamber, we separate only gas and inject this gas to the water. That is why it's much more clear. And finally, for the tests at NAQAA, the machine was monitored 2 weeks every 1 hour for the key consumables. I will clarify here. So this is free available chlorine output efficiency. What do we mean here? Real by theoretical. Theoretical is what you can calculate based on the Faraday law, based on the current level. So it is like theoretical. And the real were measured by photometer. By the real DPT tests. So the interesting thing that the average result which we got was 104%. Why? In fact, this is, I guess it's interesting.
The salt is more interesting.
If this is a proof that we have not only chlorine in our solution, we have some other oxidants. When you do DPT test, all oxidants, they react for this DPT test. And that is why we have got the result more than chlorine can give, 104%. Because some other oxidants, like hydrogen peroxide, they also contribute to this test. Second, this is power consumption per 1 kg. So they measure the real power consumption of the machine, and taking the amount of chlorine which is produced, we get the figure even better than we claimed in the presentation. So it is 3.52 kilowatt per 1 kg of active chlorine. Traditional sodium hypogenerators, they will have 6-7 kilowatt, something like this. And the salt consumption, we got 1.96. Traditional sodium hypogenerators, they have 3 kg per hour. So we have 2 kg of salt for 1 kg of chlorine. Traditional systems, they consume 3 kg of salt per 1 kg of chlorine. This is the layout for the main project for NAQAA. So the system will be in container, so it's porta cabin or containers, and the brine system is outside. For each project, we give detailed Excel sheet, Excel file, where your OPEX are much more detailed listed. Like what is the price for each consumable, how much you consume per 1 kg, how much you consume per day, everything. So this is the summary of economic feasibility for NAQAA. I have spoken about it, but just once again, they spend now with chlorine dioxide for the whole plant around $3,000 per day. With our system, it will be around $280 per day. So their savings will be around $1 million per year. Now we will shift to another part of water supply, which is wastewater. We also get very interesting results this year. This is a project with TAWZEA company in Riyadh for industrial sewage water disinfection. It is 30,000 cubic meter per day. This is the plan, the system. The core interesting thing I would like to draw your attention to. Yes, we again reached the number of 60% OPEX reduction, and the ROI like 3 years. They are more or less similar for many projects. But the core thing is with the residual. So there, you know, sewage treatment plants, they have a contact time tank. They call it contact time tank. After the sewage is treated, they dose sodium hypochlorite before this contact time tank, and usually the time in this tank is around 30 minutes. So the sewage is passing through this tank for 30 minutes to give time for reaction, for disinfection. So their dose with sodium hypochlorite was 10 ppm, 10 milligrams per liter, and their residual was maximum 0.5 after the contact time tank, after 30 minutes. With our solution, they proved it, tested it many times, because when they get first results, they didn't believe me. 8 ppm dose, so we reduce it by 20%, and the residual was 2 ppm after the same contact time tank and residual time. So this was very interesting results. They even had to shift to another photometers because their photometers was to measure ppm less than 2, from 2 to 0. And here sometimes they got the result like 2.2, 2.3, so they need to measure it by another photometer. By this, we again prove the fact with mixed oxidants, your additional savings will be not only direct savings, which we calculate, apple to apple, sodium hypochlorite and here. Your additional savings will be because of dose reduction. You will be able to reduce the dose and to get the same or better residual. This is the main project which we are discussing with them now. In January, we will install first machines for Palm Jumeirah STP, a sewage treatment plant for Dubai Municipality. And if everything is fine, they will go for 2 big desalination plants, Jebel Ali and Al Warsan, which is 1 million cubic meter per day. I think I have added it here. Yeah. For this project, some sort of confidential information. For this project, they asked us to make a comparison with real companies, with other companies. So we have chosen a well-known company from Italy and an electrolytic company from USA who produce chlorine gas on site. For the same, the capacity of the project here is 12 tons per day. So the quotations were for the same amount, 12 tons per day. So for the salt, you can see the NORA generator is 2.5, electrolytic, they claim similar to us. Power consumption, we consume 4.1 kilowatt for the whole system. The NORA 7.7 kilowatt, 4.4 kilowatt. So this is the OPEX comparison. And again, what I was speaking, you can imagine how much money you will spend on this extra when you produce 12 tons per day of active chlorine. For the capex, our system consists of 40 units. Their units are bigger, but again, to my opinion, this is better because let's say if your generator, which gives 20 kg per hour, is broken, you lose 20 kg. Our generator maximum is 3 kg per hour, so you lose only 3 kg. Electrochemical cell membrane lifetime, our is much better because we use ceramic. And what is important that the layout of our machine is only 500 square meters and their system is around 2000 square meters. And the price were also better. So here, for sodium hypochlorite, Dubai Municipality, for these 2 sewage treatment plants, they spent $18,000 per day. With our solution, it will be around 10, so 55% OPEX reduction, and savings per year is around $3 million per year. Okay, so thank you for listening all this. Now just for refreshment, and after this refreshment we will go for coffee refreshment. Let me show you just one interesting video. I will start with this because I know all of you are very busy, so maybe not all of you will be till the end for the live presentation, so we will do live presentation on the video. This is a real machine, 3 kg per hour, the biggest one. It has 24 cells, and I will just generate it on site. So you can see the 2 outlets from the cell. This outlet, you can see some gases here are synthesized, so these gases are mixed oxidants. the foam which you can see is the brine solution which was not converted. And further, there is in the middle, power supply on the top. So in the middle we have titanium separator, titanium tank, where we separate gas and the brine solution. Brine solution we fully separate and it goes back to the cycle, to the electrolysis, and all the gases which you see here, they are separated and going out for disinfection. In the second outlet from the cell is caustic soda solution, which is generated as a byproduct. So it just circulates in the machine and the excessive amount of caustic goes out by gravity. So it is looking like this. I have made a slow motion, sorry. AQUACHLOR 3000 mixed oxidants generator by Emerald company. 3 kg per hour. This is the brine pump which fills the brine into the cells on site. It has some slow motion. Okay, this is clear, I think. And just finally, we will show this. This is the test
at human disposal.
A very easy test. I will give some comments and then you will see the live demonstration. This is to show that mixed oxidants with lower concentration of active chlorine has oxidation power much higher than sodium hypochlorite. So in this test we have hydrochloric acid, 38%, fully concentrated. This is just to show that this reaction is not because of pH, not because of pH level. This is sodium hypochlorite 12%, and this is our solution 0.1% in active chlorine. If you take your phone and divide 12% by this, you will get 120. It means the concentration in active chlorine here is 120 times more than here. And we add just a universal ink. It is just organic, pure organic ink, which you use for pencil. Why we use the ink? Because the dye in ink, which gives the color, compound which gives color, it is very strong organic compound. It is very difficult to oxidize. If solution can oxidize the dye in ink, it will disinfect microbes like instantly. So just have a look how it will react. We add 5 drops. No AI fakes, fully real video.
Proven.
Look how quickly the ink is oxidized in mixed oxidants. And now we speed up video just to show that sodium hypo, it will also oxidize it, but only in like 6 or 7 minutes. You see it becomes again transparent. Yeah. So 7 minutes and 23 seconds. So the concentration in active chlorine, which we say here, is 120 times lower in mixed oxidants, but the time of oxidation is around 120 times faster. Okay, thank you.
What's the oxidative power of mixed oxidant in terms of volts?
You mean
Compared to ozone?
ORP? You mean ORP?
ORP.
It depends on concentration, but it will be like plus 800, plus 850 millivolts, plus 900 millivolts. So it will be very high. Denise, may I ask you to help me with some real test? So this is an example of this solution, which we just took for exhibition. It's around 0.1%, as I told you. And this is sodium hypochlorite. You can see it's yellow, 12%. We just bought it yesterday, so it's fully fresh, 12%. So let's put, this is the ink. Let me do it here. And we will go for the coffee. So I will add like 5. 1, 2, 3, 4, 5. We can start timer. It will be like something 5 minutes. What is good about this thing, concentration is like 0.1%. I take it always to business trips, to clean toilet in the hotel, but you can also do like this, like this. It's a bit not pleasant, but it's quite safe.
Is it available in gas stations?
Only from the machine.
You can do an advertisement.
In medical hospitals during COVID, people they were they smell it with like a fog. They use a nebulizer, nebulizer. They added this solution and smell it like a fog to clean viruses from the nasal system.
You can do an advertising. Good for face, good for toilet. Which is
Yes.
it will sell a lot. It will sell a lot.
With sodium hypochlorite, nobody will do like this because it's super concentrated. And look how it will. I do this just to show you that it is really diluted. It is not super concentrated and quite safe. So I just put it here. And let's do the same. 1, 2. So now I hopefully make it. I think you see that difference. Yeah? Just in a few seconds, it becomes quite transparent. So this one is lucky. Yeah.
It works on odor also?
Sorry?
Odor.
Yes, it has chlorine odor. You can try.
No, odor, bad odor. It removes bad odor. I can see the
Yes, yes, yes.
You have the seaweed smell, in your water.
So thank you. This
What
is
will happen?
like
What will happen if you add from the oxidant to the first water, which you put the lead? Can you?
to sodium.
Yes. To the first solution.
Why?
React quickly. Also the
No,
same.
it's better not to mix different chemicals.
This is what I mean.
Better not to mix. Okay, so I will be happy to answer any questions, Ramis, or we will. What is the schedule? I don't know the time.
And we can have the question answers if there is anything. Otherwise, we can move for a short break, and till the time we can set up this one for the live demonstration.
So if any questions, please, we are more than happy to.
Just one, how we could control the dosage for the mixed oxidant?
Yeah, by active chlorine. We measure everything by active chlorine.
And we have an analyzer or we have sensor for that?
Yes, yes.
This is exactly
Same sensor which you use for chlorine gas, for sodium hypochlorite, same sensor, which measures active chlorine. You don't need any, like for chlorine dioxide, you need specific sensor for chlorine dioxide. Here, no, just sensor for active chlorine. It is installed in the network, in the potable water, and you can control the residual chlorine.
And we can see on the monitor what is the
Yes,
dosage.
yes, yes. Definitely. It shows, when you start it, it shows current level and it shows how much grams of active chlorine machine produce per hour. And you can also, again, from our web server, we can give these results to your SCADA system and you can show it in the SCADA system.
We have a challenge in the sewage treatment plant. This part of Middle East, we have a challenge of ammonia, presence of ammonia in the treated sewage water, in the TSC water. What is the reaction of this one with the ammonia? Compared to sodium hypochlorite or chlorine?
We checked it in Dubai Municipality project. This solution, hypochlorous acid, it can oxidize ammonia.
Faster, what's the rate compared to chlorine gas or sodium hypochlorite?
Rate, you mean speed? Or
Speed with which it reacts. Not quantity, dosage rate.
It's after 30 minutes retention time tank, it will be reduced by 45, 30% from the initial value. At the dosage rate of around 8 ppm. It will be, ammonia will be reduced by 30, 40, 45%. That is what we see in real cases.
But normally there is no ammonia in the outlet of the treatment plant. It's actually in the.
Unfortunately, it is there.
Yeah, it is there.
It should not be.
Treatment plant's not working.
It's not working. It is one of the challenge during the summer. It is very usual, routine we can find. And follow that, if you store the TSC water or the policy purpose or RO intake, there will be algae. How this will be effective with algae?
Algae, we have made quite a lot of lagoons project.
Yes, lagoon.
And we see that this solution, it removes algae very, very efficiently. You can remove any type of microbes with this, like fungi, spores, bacteria, viruses, any type of microbes. And of course, algae, yeah, sorry.
You know, this part, algae here in Middle East, carcerate, very difficult to react with the chemical, chlorine.
We now hope to make Dubai Fontaine project because they also have this issue. The disinfection for lagoons is not so professional as for water treatment plants. There is just a bolt, they take calcium hypochlorite and so then it cannot remove algae. So then algae is growing, mosquitoes are growing, and these cycles happen again and again. So hopefully we will prove it in Dubai Fontaine soon. Oh.
Normally on large treated sewage treatment plants, we have treated water storage tanks. So after the chlorination is done, gas chlorine we have on site, we store it in, there are large tanks which have 12 to 24 hour storage. So if this technology is applied with mixed oxidants,
Yeah, it's better.
it is so the ozone oxygen will go out. So it will be the residual, it is the gas chlorine which will provide the residual in the tanks.
Yes, yes. And for the tanks, I can tell we have a experience in Russia, in St. Petersburg, where we are. Why is it shooting? We have experience.
Open the curtains. Open the curtains.
It's okay.
We don't need discotheca, you know. This disco. There is a procedure for disinfection of the tanks. Usually they make like 50 ppm solution from sodium hypochlorite. They make 50 ppm solution, fill all the tank, and keep it like for 24 hours. This is the standard procedure. Then you need to dilute it 10 times and drain. So your costs on water are enormous to disinfect the tank. With our solution, we make it around 20 ppm, and 2 hours is enough. to reach the same effect for disinfection. And since the concentration is lower, you don't need also to dilute it so high. So for keeping the internal part of the tank clean, this is very nice. Yes, please.
Have you any experience of pilot study done on the seawater desalination feed side? Because most of the most that we face over here in this region is biofilms, and how is your product or mixed oxidant dosing is effective than the conventional dosing of shock chlorination?
Yeah, thank you. Very good question. We have now reached agreement with AquaPower, with Thomas Altman, to do research in Riyadh. They have quite a big, in Saudi Arabia, not in Riyadh, in Jeddah. They have a big pilot plant there, and we will definitely test the efficiency on seawater. And I hope with the NAQAA Desalination plant we will also do in 2026. Here, definitely the results should be very interesting, because this solution, I will show you my slides. We have also made some projects for not only for disinfection of water, but for purification of water. Because you see this test, it has very good oxidation power, so it can oxidize iron, manganese, organic compounds, which is needed for pre-purification of seawater before the membrane. For example, these are two cartridge filters, just polypropylene cartridge filter, 20 micron. Before this one, we injected oxidants, and you can see it becomes orange because of iron. Iron can be instantly oxidized from bivalent form to 3-valent form, and it can be kept on the filter. Same with manganese. Here we use caustic soda, because very interesting effect of caustic soda solution which we produce, because it is fresh, it can work like coagulant and flocculant. The ORP of caustic soda is like -1000. So when you add this caustic, it causes destabilization of colloid particles, and they become to glue. That is why our caustic, it can be used as coagulant and flocculant also. Not only to increase the pH, of course it will increase the pH, but it will also help, for example, to eliminate heavy metals. Because this black filter, it is heavy metals, which are kept. Without this chemical, it will be just white, nothing. Same in the swimming pool. We start to dose caustic before filtration system in the swimming pool, and a lot of this, it is called biological effluvia, or biological things. When we swim in the swimming pool, a lot of things go into the water from our bodies, and they are very difficult to be filtered. Sand filters, they cannot keep it. With adding of caustic, they start to coagulate, and you can filter it. So definitely we see a very good potential for seawater disinfection. Hopefully, all now desalination plants, all now they use shock chlorination, because you know this story. They first, when you do continuous chlorination with sodium hypochlorite, microbes become adapted, and you create more and more food and biofouling on the membrane. That's why they do shock chlorination. But hopefully, we want to prove it with this solution. Maybe the shock chlorination will be working. Because, continuous chlorination. Small dose, like 0.1, 0.2 ppm, but continuously. In this case, you will not be allowing microbes to get to the membrane. So we need to prove this. Yeah, please.
Chlorine
in any form is an oxidizing agent, right? It just burns anything that comes in its path. So how do these microbes can get immunity to chlorine? This is chlorine. How can they grow in spite of free chlorine being there in the water?
How resistant?
How can they resist chlorine if it's an oxidizing agent?
Because microbes, the problem is with biofilms. And
They are under the biofilms.
yes, because biofilms, it's like an independent city, you know. They have their border, they have their guards who protect the living in this city, and they accumulate in the internal surfaces of the pipes, of the tanks. It is very difficult to oxidize it. And hypochlorous acid, it has ability to penetrate through this wall in the biofilm. Hypochlorite, the practice show it cannot do this. Many people say that, okay, sodium hypochlorite, when you dilute it in water, it also gives you hypochlorous acid. But in practice, this process is not going fully, because the results are proving this. Sodium hypochlorite does not have this oxidative power.
So this has a dispersant power also, you see, to disperse the biofilms, right?
Yes.
Sorry, additionally, because the bacteria is there because there's food in the water. And this is disinfection is also, it says, as oxidizer, then eliminate also the rest of organs, which the bacteria then live on that. That means this biofilm, this is, of course, the bacteria, this is, but also...
Yes, you remove the food for bacteria.
This is...
Let's say sodium hypochlorite, it usually contains salt, sodium chloride. In this, not only active chlorine, it has water, besides of active chlorine, it has water and salt, table salt. So when you dose it into the network, it forms the sludge. It's very well known. If you look at the non-return valve by which you dose sodium hypochlorite, if you look to the non-return valve, it will be in 1 year very clogged with salts, with slime, with salts. The same is happening in the network. When you dose it, you create the sludge in the network. And this is again the food for the microbes. Here you inject only pure gases in the water. So it is not increasing TDS anyhow. TDS will be the same.
Does it work effectively? Do we require a pH, particular pH range? Is it a pH dependent?
You mean pH of water? To be honest, this was our worry when we started with NAQAA, because most projects in Russia for river water, the pH there is around 7, and here the pH is 8.5. So, but the results which we gave are same here. It can definitely work for 6 pH, 7, and we proved it can work for 8.5 pH as well. So we don't see big dependence here.
Any difference with the temperature?
Sorry?
Any difference with the temperature, even with the high temperature?
Here I can say that this chemical will react very similarly as all others. If you have higher temperature, the degradation rates will be higher. So in terms of degradation, I showed you the timeline for, we see that it's more or less similar. Chlorine dioxide, sodium hypo, mixed oxidants, degradation rate of active chlorine is similar. Everybody are a bit tired. Ramis, we need to do a coffee break. Thank you very much, gentlemen, for coming. Ladies. We are here with Ramis till the evening.
So we have arranged for a small break, a coffee break, and after that we will have this live demonstration. Okay.
Thank you.
Emerald, nature-like technologies at human disposal.